In this video, we will make this Bluetooth speaker which is more than just a speaker with all the LEDs on it that react according to the music you are playing. It looks super cool and you can decide whether you want to turn on the LED or not to save battery and consequently get a longer playtime. Let's start with this quite famous Bluetooth module. You just need to have a quality speaker and a 5V power and you can listen to songs over Bluetooth very easily. For the lighting part, you will need this MAX9814 module which is just awesome and I love it. For the LEDs, I will use my favorite WS2812B, the 60 LEDs per meter version. I cut 2 strips having 10 LEDs on each because right now I think that will be a decent amount to use considering the size of the speaker, but later I shorten it down to 8 LED on each strip. For prototyping, I'll be using Arduino Uno, but later I will replace it with a Pro Mini. I made connections according to the circuit diagram. Then I uploaded this sketch and quickly checked if the LEDs are doing what they're supposed to, which is reacting to the sound of course.
Choose device is ready to pair.
Time for some measurements. I took my time to measure everything and make a plan for the enclosure I'm going to build. This is necessary because once the material is brought down to size, you have to do a lot more to change it if anything goes wrong. Unlike electronics in which you can just change a line and upload it again, or desolder a wire and solder it to the correct place. So if you're going to design your own enclosure, do it with patience and very carefully. After my planning was done, I drew outlines on the material I am going to use, which is a 12 mm thick MDF. Do this step quite carefully too, as a 0.5 degree error at start point can become a couple degree error after traveling a distance. Better use a tri-square and check the dimensions after the outlining is completed. For cutting, I will be using a regular blade for straight lines and a curve cutting blade for cutting the hole of the speaker. I started cutting from the speaker hole. For removing unevenness, use a file. After I was sure that the speaker would fit in perfectly, I moved on to cut straight lines. I cut the shorter length sides first and then went for the longer length sides and cut them all at once. You might want to be careful while choosing the speed with which you are cutting the wood. Less speed is good for curved cutting, while for straight cutting with a regular blade, you should definitely use higher speed. Using glue, I have stuck all the sides together. I have marked the speaker depth inside the enclosure as well as the height required for the LEDs to diffuse through an acrylic sheet completely, which is around 1.5 cm. Now, keep in mind that while placing the components, nothing should be within these marked lines. I marked holes for fixing the speaker and drilled it using a fitting drill bit. After marking the hole for the switch I'm going to use, I made the cut using drill and jigsaw. Curve cutting blade is perfect for this kind of job and I made the cut in no time using just that. Whereas drilling several holes would have taken a lot more time as filing is required after the drilling process. For the micro USB breakout, first I made marking, then drilled 2 holes using a small drill bit wide enough to let the jigsaw blade pass through it, and then I completed the cutting with the curve cutting jigsaw blade. And at this point, I must say I love this blade. To make the enclosure look good, I cut carbon fiber vinyl for all the 5 sides. I cut them a little bigger than required and after sticking to their respective sides, I removed them using a sharp blade. While I was at cutting things, I also cut the acrylic sheet after measuring the top of the enclosure. I drilled holes of size of the nuts I will be going to use. Using the same holes as guide, I made markings on the enclosure where to drill the holes to fix the sheet, and then drilled it out using a drill bit one size less than used in the sheet. So after all this, I soldered 2 wires to the lithium-ion charger input. I fixed the battery and the step-up converter at one corner with some hot glue. Then I took 2 sets of 2 wires and shorted them at one end. I will solder the shorted end to the Bluetooth MP3 player module, and from the other end, one wire goes to a switch and other will go to Arduino. The wire soldered to the lithium-ion charger input can now be soldered to the micro USB breakout board, and the board can be fixed in its place with some hot glue. To reduce the wire hassle, I made a small PCB with Arduino and the sound sensor on it with all the connections. The connection is really pretty straightforward and will not require much time to complete. After this, I checked if the circuit powers up by shorting the 5V wires. And it doesn't. Found out that the battery is dead. Luckily, I had another one. So I prepared it and replaced it in its place and also stuck the Bluetooth module to one corner. Using a thin white cardboard, I made a tray like this in which I will mount the LEDs. I made 3 holes for power and data in wires and soldered them to the respective places. I shorted the power and data wires on both the strips. For shorting the data wire, I used the previously used technique. Using a FTDI board, I uploaded the sketch to Arduino. I put everything to place, and before finally setting all up, I tested the setup by shorting the wires to the battery, and everything works fine. The pin 7 is used for deciding whether the LED will be on or not. When it is high, LED must glow, and when it's not high, LED must be off. As you can see here, the yellow wire is connected to pin 7 and is left open, and the LED is not glowing, but as soon as I touch it, LED turns on. This is due to the fact that leaving a pin open means it is floating, that is, it is neither high nor low, and this should not happen. So to fix it, I pulled the pin 7 low using a 10 kilo ohm resistor. Now you will see that it is working fine, and the LED only glows when it is connected to 5 volt. But when I disconnect the 5 volt from pin 7, the LED doesn't turn off and show the color constantly that was glowing just when the 5 volt was removed from pin 7. This is because of a reason. Although the Arduino has stopped sending data, the power is still available to the LEDs. While this can be easily fixed, we won't be needing it, as to switch the LED to off mode, the Arduino has to be restarted and the LED will remain off. Alright, we are very close to the finish line. For strength, I added hot glue to the soldered wire wherever necessary. Coming to the switch connection, I shorted both the middle terminals and soldered the 5 volt from step-up converter to it. I also shorted the 2 ports of any one side so that it doesn't matter where the switch is moved, the Bluetooth module and Arduino should turn on. The difference will be in the fact that I soldered the pin 7 of the Arduino to any one of the remaining pole. In this way, the pin 7 will get connected to 5 volt or ground, indicating the Arduino to turn on or off the LEDs. I made the connections as I described and everything is working fine. Flipping the switch to one side turns on a Bluetooth speaker and Arduino on, and flipping it to the other side makes everything on. Without wasting any more time, I quickly soldered the speaker wires to the speaker. Using a little hot glue, I fixed the switch at its place. Then I attached the speaker at its place using fitting nuts and bolts. For a place hard to reach, I came up with this method, which has a tweezer and 2 neodymium magnets holding the nut just to slip into the bolt, after which you can easily tighten it with a nose plier and a screwdriver. Now place the LED tray at its place and just check once, and then screw the acrylic sheet on the top and we are done. If you appreciate our work and if it helps you in any way, please like, share and subscribe. Thank you guys for watching. Till next time.